Hi everyone, I'm Arya, an electrical tutor working with EWRB. Today I would like to start this audio review questions series to go together with the audiobook based on the EWRB Electrician teaching guidelines. Please listen to the audiobook first, then use this audio review to test your understanding. Let's get started. Hi everyone, I'm Arya. Let's start our topic review. Before we begin, I just want to mention one thing. These review questions may contain mistakes. If you notice any mistakes, please point them out in the comments. I will double check them. If anything is corrected or updated, I will add the fixed questions in the video description below this video. So, when you listen to this audiobook, please check the description first. Thank you. Now, let's start. Topic 23. Single-phase motors. Listen carefully. Choose an option, wait for the countdown, and then check the explanation. Review question 1. Why cannot a single-phase induction motor start on its own without a starting method? Option A, because the supply voltage is too low. Option B, because it produces only an alternating magnetic field. Option C, because the rotor resistance is too high. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. A single-phase supply produces an alternating magnetic field, not a rotating one. This field moves back and forward but does not rotate. Because there is no rotating field, no starting torque is produced. The rotor only vibrates and cannot begin turning without assistance. Review question 2. How does a single-phase induction motor continue running once it is already rotating? Option A. By centrifugal force only. Option B. By induction caused by the moving rotor. Option C. By increased supply voltage. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Once the rotor is already moving, the alternating magnetic field can induce current in the rotor. This induced current interacts with the magnetic field to produce torque. That is why a single-phase motor can keep running after it has been started. Review question 3. What is phase splitting used for in single-phase motors? Option A. To reduce noise. Option B. To create a rotating magnetic field for starting. Option C. To improve insulation strength. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Phase splitting creates two magnetic fields that are out of phase with each other. Together, these fields act like a rotating magnetic field. This rotating effect produces starting torque so the motor can begin turning. Review question 4. Which component creates phase shift in a split phase, resistance start motor? Option A. A capacitor. Option B. A high resistance start winding. Option C. A permanent magnet. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. In a split-phase motor, the start winding has higher resistance than the main winding. This causes the current in the start winding to lag differently. The phase difference between the two currents creates starting torque. Review question 5. What device disconnects the start winding in a resistance start motor once it reaches speed? Option A. Thermal overload relay. Option B. Centrifugal switch. Option C. Circuit breaker. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. The centrifugal switch opens when the motor reaches about 70 to 80% of rated speed. This disconnects the start winding to prevent overheating. After this point, the motor runs on the main winding only. Review question 6. What is the main disadvantage of a split-phase motor? Option A. High cost. Option B. Low starting torque. Option C. Poor running efficiency. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Split-phase motors produce only moderate starting torque. They are not suitable for heavy loads at start. They are best used for light-duty applications like fans or small tools. Review question 7. How does a capacitor start motor improve starting performance? Option A. By increasing resistance. Option B. By creating a large phase shift. Option C. By reducing supply frequency. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. The capacitor causes a strong phase shift between the start and main windings. This produces a much stronger rotating magnetic field. As a result, starting torque is significantly higher than split-phase motors. Review question 8. Why is a centrifugal switch still required in a capacitor start motor? Option A. To reverse direction. Option B. To disconnect the start capacitor and winding. Option C. To control speed. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. The large start capacitor is designed for short time use only. Once the motor reaches speed, it must be disconnected. The centrifugal switch performs this function automatically. Review question 9. What is a key feature of a permanently split capacitor, PSC, motor? Option A uses two capacitors. Option B has no centrifugal switch. Option C has very high starting torque. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. PSC motors use a single capacitor that stays connected at all times. Because there is no centrifugal switch, the design is simple and reliable. Starting torque is lower, but running performance is smooth and efficient. Review question 10. Why is starting torque lower in a PSC motor compared with a capacitor start motor? Option A because the capacitor value is smaller. Option B because the start winding is disconnected early. Option C because supply voltage is reduced. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. PSC motors use a smaller capacitor designed for continuous operation. This produces less phase shift during starting. As a result, starting torque is lower than capacitor start motors. Review question 11. Which motor type uses two capacitors for both starting and running? Option A split-phase motor. Option B capacitor start capacitor run motor. Option C shaded pole motor. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. This motor uses a large capacitor for starting and a smaller capacitor for running. The start capacitor disconnects once speed is reached. The run capacitor remains connected, giving good efficiency and smooth operation. Review question 12. Why are capacitor start-run motors suitable for heavy single-phase loads? Option A they run at synchronous speed. Option B they provide high starting torque and good efficiency. Option C they have no moving parts. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. High starting torque allows the motor to start heavy loads. The run capacitor improves efficiency during normal operation. This makes them ideal for pumps and refrigeration compressors. Review question 13. Why are start relays sometimes used instead of centrifugal switches? Option A. To increase torque. Option B. To eliminate moving parts inside the motor. Option C. To reduce current draw. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Start relays operate electrically instead of mechanically. This removes moving parts inside the motor. They are useful in sealed motors where centrifugal switches may fail. Review question 14. What motor type can operate on both AC and DC supplies? Option A induction motor. Option B universal motor. Option C synchronous motor. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Universal motors use a wound stator and rotor with a commutator. Current reverses in both at the same time, so torque remains in one direction. This allows operation on either AC or DC. Review question 15. What is the main disadvantage of universal motors? Option A, low speed. Option B, brush wear and noise. Option C, poor starting torque. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Universal motors use brushes and a commutator. Brushes wear over time and produce electrical noise. This limits their lifespan compared with induction motors. Review question 16. Why do shaded pole motors have very low starting torque? Option A, because they use DC supply. Option B, because the rotating field is very weak. Option C, because the rotor is very heavy. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. The shading ring delays flux in part of the pole. This creates only a weak rotating magnetic field. As a result, starting torque is very low. Review question 17. What is the main advantage of shaded pole motors? Option A, high efficiency. Option B, very low cost and simplicity. Option C, high starting torque. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Shaded pole motors are extremely simple. They do not use capacitors or switches. This makes them cheap, reliable, and easy to maintain. Review question 18. Why do single-phase synchronous motors run at constant speed? Option A, because slip is very high. Option B, because the rotor locks to the rotating field. Option C, because resistance is low. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Once synchronized, the rotor magnetic field locks to the stator field. The rotor speed exactly matches synchronous speed. Load changes do not affect speed unless the motor pulls out of synchronism. Review question 19. Why do universal motors allow easy speed control? Option A, because they use capacitors. Option B, because voltage can be varied electronically. Option C, because they have multiple windings. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Universal motors respond directly to voltage changes. Electronic controllers such as triacs vary the voltage. This provides simple and effective speed control. Review question 20. Which application commonly uses PSC motors? Option A, heavy hoists. Option B, fans and air handling units. Option C, large compressors. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. PSC motors run quietly and efficiently. They are ideal for continuous duty applications. Fans and blowers benefit from smooth operation. Review question 21. What happens if a single-phase induction motor is manually spun in the correct direction before power is applied? Option A. It will trip immediately. Option B. It may start and continue running. Option C. It will run in reverse only. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. If the rotor is already moving, the alternating magnetic field can induce rotor current. This allows torque to be produced in the direction of rotation. This behavior proves that the motor itself is capable of running but lacks starting torque. Review question 22. Which component mainly determines the phase angle between start and run windings? Option A, rotor bars. Option B, resistance or capacitance in the start circuit. Option C, supply frequency only. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Phase angle is controlled by resistance or capacitance. High resistance gives a small phase shift. Capacitance gives a much larger phase shift and stronger starting torque. Review question 23. Why must start capacitors be rated for short-time duty only? Option A, they are connected to DC. Option B, they overheat if left in circuit too long. Option C, they reduce motor speed. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Start capacitors are designed for high current but short duration. If left connected, they overheat and fail. That is why they must be disconnected after starting. Review question 24. What fault is most likely if a capacitor start motor hums but does not start? Option A, open main winding. Option B, failed start capacitor or switch. Option C, excessive load only. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. A failed capacitor or open start circuit prevents phase splitting. Without phase shift, no starting torque is produced. The motor draws current and hums but cannot rotate. Review question 25. Why do PSC motors generally have better running efficiency than split-phase motors? Option A, because the capacitor improves the running power factor. Option B, because resistance is higher. Option C, because they disconnect the run winding. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. The permanent capacitor improves phase balance during running. This reduces reactive current. Better power factor means improved efficiency and smoother operation. Review question 26. Which motor type is most sensitive to incorrect capacitor value? Option A, shaded pole motor. Option B, PSC motor. Option C, universal motor. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. PSC motors rely on a correctly sized capacitor at all times. Incorrect capacitance causes overheating, poor torque, or noise. Capacitor value is critical for correct performance. Review question 27. What safety risk exists if a centrifugal switch fails to open? Option A, reduced speed only. Option B, start winding overheating. Option C, loss of direction control. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. If the start winding remains connected, it carries current continuously. Start windings are not rated for continuous duty. This leads to overheating and insulation failure. Review question 28. Why are shaded pole motors unsuitable for high load applications? Option A, they cannot run on AC. Option B, their starting torque is very low. Option C, their speed is too high. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Shaded pole motors produce only a weak rotating field. This gives very low starting torque. They are suitable only for very light loads. Review question 29. Which motor type produces the highest speed relative to its size? Option A, PSC motor. Option B, universal motor. Option C, shaded pole motor. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Universal motors can operate at very high speed. They have an excellent power to size ratio. This makes them ideal for portable tools. Review question 30. Why are universal motors noisy compared with induction motors? Option A, high magnetic losses. Option B, brush and commutator operation. Option C, low efficiency. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Brushes and commutators create electrical arcing and mechanical noise. High operating speed increases sound levels. This is a known trade-off for compact high-speed operation. Review question 31. Why do synchronous single-phase motors require a starting method? Option A, because they have no rotor current. Option B, because they cannot produce starting torque on their own. Option C, because they use DC supply. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Synchronous motors cannot develop starting torque by themselves. They must be brought close to synchronous speed first. Once aligned, the rotor locks to the stator field. Review question 32. What determines the running speed of a synchronous single-phase motor? Option A, load only. Option B, supply frequency. Option C, supply voltage. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Synchronous speed depends directly on supply frequency. As long as the motor remains synchronized, speed does not change with load. This makes synchronous motors ideal for timing applications. Review question 33. Why are universal motors not commonly used for continuous industrial duty? Option A, poor starting torque. Option B, excessive maintenance due to brushes. Option C, low power output. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Brushes wear and require regular maintenance. Continuous operation accelerates wear. Induction motors are preferred for long-term industrial use. Review question 34. Which single-phase motor type has the fewest components? Option A, capacitor start motor. Option B, PSC motor. Option C, shaded pole motor. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option C. Shaded pole motors use one main winding and shading rings. They have no capacitor, switch, or relay. This simplicity makes them cheap and reliable. That finishes the topic 23 review. Listen again, choose an option, wait for the countdown, and check your understanding.